this video, we're going to look at factoring review, and this is to help us be successful for all of Unit 6 with rational expressions. For most of the problems that we do in Unit 6, the first step is always going to be to factor. So in order to be successful, we need to be really good at factoring. So we're going to look at a couple of different cases for factoring. The first one being when we have two terms. So if you have two terms, something that looks like this, 25x plus 15. Right now I'm looking at our 6.1 note sheet, and this is number 1. So if we're looking at 25x plus 15, and I look at that problem compared to something like number 7, where we have x squared minus 16. So both of these problems have two terms. They both have x's in them, they both have numbers, but they're going to factor very differently. Number 1 is a problem in which you factor by factoring out the greatest common factor. So if you look between 25x and 15, the greatest common factor there is 5. So you're going to divide 5 out of each of your terms. And what are you left with? You're left with 5x plus 3. This is completely factored. I've taken my expression and I rewrote it to be in terms of things that you multiply together to give you the 25x plus 15. And that's 5 times 5x plus 3. So 5 is a factor, 5x plus 3 is a factor. In number 7, what we have here is what we call a special case. And this is anytime you have a variable squared minus a number that is a perfect square. So perfect squares are 1, 4, 9, 16, 25, 36, 49, and so on. Perfect squares are the numbers that when you take the square root of, you get an integer. So x squared minus 16, 16 is our perfect square. The square root of 16 is 4. So when you have x squared minus a perfect square, it factors to be x plus and x minus the square root of this number right here. So it's going to be 4 and 4. To give you another look at a problem like number 7 is number 8, 3x squared minus 75. Now this problem actually combines together both of these concepts, because the first thing you're going to do here is factor out the greatest common factor, and then you're going to have a special case. Because right now I have x squared minus, but this is not a perfect square, this is not a perfect square. But between both of these terms, we can factor a 3 out, and what we're left with is x squared minus 25. And now this is a difference of squares. We have our special case. 25 is a perfect square, the square root of that is 5. So then this can go one step further, 3. We have x plus, x minus, the square root of 25 is 5. And that is your complete factoring. Okay, so those are those are the two types of problems that we deal with where you have two terms. It's either a greatest common factor or it is a special case. So now let's take a look at problems where you have to factor with a quadratic. So let's take a look at number 6. So number 6, we have 6x squared minus x minus 35. So you always look to see, is this a value a greatest common factor? Can I take it out from all of my terms? And we cannot. So we can't take that a value out. So what we have to then do is we factor using either the M method or the box method. So I'm going to go forward with the M method. M method. The purpose of drawing the M is it helps guide the terms of 1. So we're going to bring down the 6x squared, bring down the minus 35. Multiplying A times C, 6 times a negative 35 gives us negative 210. What we're going to do with that number is we're going to list all of the factors of negative 210. And when we're doing that, we're trying to find the one that's going to add to give us negative 1. Because right here is a negative 1, and we're going to end up splitting that negative 1x up into two terms. So listing our factors of negative 210, we're going to end up going to 14 and 15. and a positive 14 and negative 15 is going to add together to give us a negative 1. 14 times a negative 15 multiply to give us a negative 210. So splitting negative 1x up into being plus 14x and plus a negative 15x. Where you place those doesn't matter, you can flip those around. Now you group together the first two terms. GCF is the 2x. What you're left with here is 3x plus 7. GCF in your next set of parentheses is a negative 5. What you're left with is 3x plus 7. You know you did something correctly because you end up with the same parentheses. That's one of your factors. What's outside of the parentheses is your other factor. So that is completely factored. The last thing that we talked about in class is the shortcut factoring. And that is for problems like number 3. Sorry, kind of jumping all over the place here. In number 3, you have x squared plus 5x minus 6. And I say that we can shortcut factor this because we have an a value that's 1. So when you would go forward and do the entire m method, what you end up finding is your factors at the end are the same things as the numbers that you use to split this minus 5x to be. So that we can just shortcut, skip all those steps, and go directly to our factors. So my factors, I have an x and an x. I would do a, which is 1, times c, which is a negative 6. So factors of negative 6 that add to give us 5. Whenever we have the 6 and 5 combination, we always have to be very careful because there's a lot of different ways that we can come up with this. So they're multiplying to give me negative. That means that one has to be positive and one has to be negative. And they're going to add to give me a positive 5. So negative 1, positive 6 is what I'm going to use to give me a positive 5. So I use negative 1, positive 6, boom, I'm done with my answer. So this is an overview of factoring all the different types of problems that we're going to see here in Unit 6.